Okay, let's give you guys some practice now. So here, sketch this graph here. So yeah, so press pause and have a go. Okay, so first thing to do is to realize that this here is a continuous graph here, because if you look at this here, this is continuous, meaning that if you draw this graph here, it will look something like this. It's continuous. Look at this one here, it's continuous. So this will be something like this. And then if you look at this one here, well, now you've this is equals 8 here, so the graph will look like this. This one here is continuous. This one here is continuous. This one here is continuous. So the sum of all three continuous functions will be the whole thing will be continuous. So the first thing to realize is that this here is a continuous graph. Okay. So now have a look at this here. So this is what we're trying to sketch here. Okay, so when x is big, it wants to do this. So it wants to do a well, in a way well, it will look like this. When it's small, when x is small, it wants to do this. So it will be a negative cubic. Okay, it's a negative cubic, and it has an intercept of 8. So it wants to do something like this. So now bear in mind that when x is small, it wants to do this. When x is big, it wants to do x to the power of 4. So somehow create it in such a way that when it's big, it will be to the power of 4. When it's small, it's to be so when it's big, it wants to do something like this. When it's small, it wants to do something like this. Okay, so now join the two up in a way, join them up. So we're going to guess it to be like this. By the way, this here, it could be like this. The turning point here could be above the x-axis, or it could go or it could go below the x-axis. So it could be like this. Okay, but the point here is that when x is big, it wants to do x to the power of 4, meaning it wants to do this and this. Okay, so in a way it's like this. In a way it's like that. And when it's small, it wants to do this. So it wants to do this. The negative cubic going through the intercept of 8. So we're going to guess it to be like this. Make it go over into the negative realm here, because we can always adjust this point here later on. We could move it up here later on if we want to. Okay, so let's guess it to be like this for the time being. So now we can see that there's a turning point here. Well, the gradient here will be, we guess it to be 0 here, and we're going to guess that the gradient here will be 0 here. So the next thing to do is to differentiate this. Okay, so differentiate this. That will then blah 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 here. So starting at our original graph here, so differentiate it. It will then give you this. Okay, so when you get to this stage here, realize that what's in common between this and this is really 2x squared here. So you can factor that out. So it looks like this. Okay, now looking at this here, when will this, so at the moment you've got this times this here. When will this whole thing be 0? This whole thing will be 0 when you make this block 0, which will be when x equals 0. And then this block, if you make this block to be 0, so when will this be 0? This will be 0 at when x is 9 over 2. Okay, so the gradient will be 0 when x equals 9 over 2 and when x equals 1. Okay, so the gradient will be 0 when when x equals 0 and when x equals this. So now we now know we now know that the gradient will be 0 here and when x equals 0. Okay, so we know the coordinates here will be 9 over 2. So we need to put, so to find out the y coordinate here, we need to put this back into here and then into here, and then work out the whole thing. So this point here, the y coordinates here will be you doing this, blah blah blah, blah blah blah, blah blah blah, and then this will be your y coordinate here. Okay, so far we've got a turning point here, and the coordinates here will be given by this. Okay, and then and now we need to now we need to what? Sorry, hang on, let me think. Yeah, so now we need to double check the gradient. So looking at this here, you can see that the gradient here is going downhill, 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 and then in this so here we've got a critical point here, we've got a critical point here. We now need to check the interval here. So you can see the gradient's negative here, and then looking at the graph, the gradient is negative, 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 and this here, so between here and here, the gradient is negative, and then now, in this region here, from here to here, it's going positive, positive. The gradient is going uphill. Okay, but let's double check everything. So looking at this here, well, we differentiated it earlier. So so we got to this stage and this stage here. Okay, we did this earlier, right up there somewhere, right up here somewhere. Okay, well anyway, the gradient, well the first derivative is given by this, and then we factor it out to give us this here. Look at both forms. Sometimes this form will be better than this form here. Sometimes this form here will be better than this form here. But look at it. So so in this region here, when x is less than 0, the derivative will be, well, we've established that the derivative will be less than 0. But let's double check. Okay. So looking at this here, when x is, well, if you look at this graph here, just quickly sketch this graph here. When x is big, it wants to do a positive cubic, so it wants to do this. Okay, but when x is small, it wants to do a negative quadratic, so it wants to do a negative quadratic. So so we're gonna guess well, we're gonna guess the curve to be like something like this. So so the graph for this derivative here is given by this. Okay, so this equation here is given by this. But then if you look at in the range of x being less than 0, you see when x is less than 0, this thing here will always be negative. This thing here will always be negative, meaning that this whole thing here will always be negative in this region here when x is less than 0. Okay, so this here is good, is correct so far. Okay, now let's check in the region between here and here. So in that region here, well, when x is when x is between here and here, well, hang on, let me think. Okay, choose. So the critical point here is this bit here is 9/2. So if we choose an easy number, let's say 1, let's put 1 into here then. Okay, 2 times 1 will be 2 times 1 will be 2. Take away 9. That this whole thing here will be a negative number, and then in this region here, this thing here will be a positive. So this is negative, and this is positive. So overall, you've got a positive times a negative. Then this region here will be a negative. Okay, badly explained, but if you press pause and think about it, in this region here, y prime will be less than 0. Okay, and then use the same argument. Y prime in this region here will be positive. So so this here seems to be correct. This here is correct. This here is correct, and it tallies up with our graph. Okay, so now let's look at the second derivative. So when you look at the second derivative, hang on. When you look at the second derivative, if you look at this here, this here is concaving up. Okay, this here is concaving up, and then when you look at this bit here, it's actually concaving down. Okay, so this bit here is concaving. This bit here is concaving up. Okay, and this bit here is concaving down. So you've got a point of inflection right here, and then looking at this here is concaving down, and then this here is concaving up. Okay, so we should have another point of inflection somewhere between here and here. Because if you look at this here, concaving down, and then here is concaving up. So there should be a point of inflection somewhere here and somewhere in here. So to deal with inflection points, to detect inflection points, you take the second derivative. So blah blah here. So y prime is given by this. Differentiate it, it will give you this. Tidy up, it will give you this. So looking at this, let me think. Looking at this, the inflection points will be at x equals 0 and x equals 3. Okay. So hang on. I'm going to zoom through this because the video has been taking a while. So y prime here, inflection point x equals 0, x equals 3, and then blah blah blah. Yeah, so blah blah. This point here will be so our inflection point here will be 3, negative 73 here. Okay, so now double check everything. So in this region here, I'm just gonna zoom through this. In this region here, f prime will be greater than 0. Okay, but by looking at this here, you can sketch this. So hang on, sketch this here. So when x is big, it wants to do a positive quadratic. When x is small, it wants to do a negative linear or gradient of minus 36. So this graph here will look something like this. This graph here will look something like this. So when x is less than 0, you can see that this is always positive. So this thing here, hang on. So this thing here will be positive. Okay, and then in this region here, well, just follow through the same process. Y prime in this region will be negative. So y double prime in this region will be negative. Should be y, not f. Okay, this here should be positive. Okay. So looking at this here, if y, I got f and y mixed up here. So okay, if f double prime, if the second derivative is greater than 0, then it's going to concave up. So this bit here is concaving up, so which is good. Okay, it makes sense. In this region here is concaving up, and then here this is less than 0, so it should concave down, and it does indeed concave down. You see, it's concaving down. This is concaving down. This is concaving up. Okay, and then from this bit, from here to here, is concaving up because this is greater than 0. So from here, it's actually concaving up. You see that? It's concaving up. Okay, it's concaving up. So everything checks out. So this is good. This is good. This is good. Okay. So our graph looks like that.